looking at here is essentially a back pressure valve. But what we did is we really evolved the valve at this point. This was actually if you want to say, the point of evolution for our valve. And what ended up happening is we had a gentleman, he was up in a very remote location, and he said, "Daryl, I've been using your valve, I've been transferred, I'm in a remote location." And what we used to do is we always thought that with our valve, we always thought that if we had wanted to maintain 100 pounds on your P1 pressure, we always thought you had to have a little bit more pressure on the outside of that expansion bottle. So basically, if you had 100 pounds here, we always thought you had to have about 101 pounds to get that valve to lock up and maintain your 100-pound set pressure. So what that did is either you had to have a higher pressure source at your facility, or we'd use some type of inert gas like nitrogen or something like that. And basically what the gentleman said is that, "I love the valve, but I just don't have that kind of flexibility here. I don't have a higher pressure source. I'm so remote, it's too inconvenient for me to have nitrogen up here. But," he said, "if you can come up with a solution," he said, "I will use your valve." So I went back to the drawing board, and it didn't really take me long. I realized, looking at the valve, that because we have a large surface area on the outside of this rubber bladder, compared to each one of these small little holes, we actually have, because of the larger area, we actually have more pounds per square inch of force down than we do up. And so what that does is that if you have 100 pounds here and 100 pounds on your P1 pressure, because we have that more pounds per square inch of force down, what it does is that actually ends up locking that valve up bubble tight. And really, all of a sudden the bells went off, because now I realized that, hey, I can actually use my process gas to control it. So basically the idea behind it was this is optional. We have a gauge in here, a pressure gauge in there. We have a needle valve. So basically when we start up, let's say you got a compressor there, a separator that you want to control pressure on. Basically what we'll do is we'll come in here, we'll open up the needle valve, and what it does is it actually pressures up the outside of the bladder at the same rate as it does the inlet of the valve. And again, as a result, it remains locked up. So this pressure will just continue to build until you hit your set point. Let's say it's 100 pounds. As soon as you hit 100 pounds, you close that needle valve, and then it's fully self-contained. One of the advantages of that, of us having it fully self-contained, is that what it does is in competition, I guess, in comparison to our competition, it gives us a huge leg up. Most of our products that we compete against, of course, because they have a spring and diaphragm, the diaphragm has a sensing line on there. And of course, if you have any kind of a slug of water, or you get carryover, your vessel goes down on high level, of course that water will get carried, or oil will get carried into the sensing line on our competitions, and will dump into the diaphragm, and we'll plug it up bad enough, typically, that it will not control properly. You physically have to pull that valve out, service it, and then put it back in. The nice thing about our valve is that this rubber bladder was really developed to eliminate the problems that you see with that. So we've had it now for about 15 years, and we have yet to come across a product that we have found that attacks it. We've gotten it into 40% H2S. We can go from -50 to 200 degrees Celsius. We've had it in 100% CO2 injection. You know, you name it. We haven't come across a product yet that affects it. And as a result, if you get carryover, and because this is all self-contained, it's all complete standalone, what will happen is that will just flow right through the valve as if nothing happened. And of course, it won't plug up our valve. We don't care, because it can flow through the valve. It can handle all that stuff. It won't plug it up. It won't jam it up. And it'll just carry on operating as if nothing happened. And of course, now that we've realized that, hey, I can use my process gas here to control the valve, what it did is, like I said, now all of a sudden the bells and whistles kind of went off, and it really helped us evolve the valve so that it can basically do everything that our competition does. So we can do back pressure, we can do pressure reducing, we can do flow control, differential pressure, dump valves, choke valves, you name it, we can do it. It's just a matter of changing out the controller. In this case here, we have the expansion bottle. We change that out, as we'll see in later applications. You'll see that by changing that out to a different type of controller, we can essentially make that valve do whatever we want it to do. And we can even do a lot of multifunction things, which is something that only our valve can do.